Hello YouTubers. I'm continuing my experiments with graphite materials, and I'm trying to call your attention. There's the DC power supply. We just started this run, 3.545 volts at constant current, 240 milliamps. In prior videos, I've defined dry and wet circuits containing graphite materials such as felt or twine. And I'm calling your attention to the device and circuit on the left here, the one shown. Just started it. Plastic container. I'll have information on it. It does not react with dimethyl formamide solvent, which is an organic solvent often used in supercaps. Our area of research involves supercap prototypes at the undergraduate level, and also suitable for home researchers, and even the graduate research professors and people in industry, researchers in industry, may see something of interest in terms of a simple, easy run. This is a wet circuit as I define it. In prior videos, I mentioned what I mean by that, and I'll simply say here it's a wet circuit with an LED as load, because I like the light versus heat with a small DC motor, moving parts, etc. This is good for a simple run. In the plastic container, however, is not DMF. In the plastic container is deep eutectic solvent, a very easily prepared, and that's with choline chloride and urea. And I will put the exact stoichiometry down, molar ratio. I think it's CHCl to urea 1:1 or 1:3, and I'll get that from my undergrad assistant, that information. And you can see the simple breadboard setup. I'm working on making some perf boards soldered, so I don't have loose wires. But for easy startup and for maybe an undergraduate class, the breadboards would be fine. We let these go, these runs continuously, day and night, for 10 to 14 days. And we're trying to see how the graphite material could possibly change resistance as it's run at constant current. And in this case, it's graphite felt, and I have 2 pieces of chromatography paper sandwiching the graphite felt in this case, and it also has a lithium tetrafluoroborate electrolyte, a well-known electrolyte. We want to see if the graphite felt with this solvent, with this electrolyte, can be run at constant current, 240 milliamps, and the voltage 3.55. Now, most of your commercial supercaps with organic solvents are quite arbitrarily kept at 2.7 volts in the industry. And we, of course, want to see if we can go to higher voltage. This would be very important with supercaps. So before creating a prototype supercap, we want to see how the graphite will perform. And of course, we'll run scanning electron microscopic examinations at the end of a run. This piece of felt has been run prior at even higher voltage current, constant current, for about 10 to 14 days, and seemed to be pretty constant. So then we stopped that run and applied the electrolytic solution. So that's where we're at with this. A dry circuit, as I define it, under these experimental conditions, would be the sample of graphite felt or twine with no application of electrolyte or DES solvent. That would be defined as a dry circuit. This is a wet circuit, as I define it, in contact with electrolytic solution. We'll keep you posted on what we find. And in our runs, in some runs that we've done, so far the one over there is at 4.8 volts with 250 milliamps. It's been running for days. It started at, let's see, can I tell you right away? Can I tell you? Okay, it started at 4.5 volts, and that was 6 days ago. It's been running day and night, and there's electrolytic solution in it. This one's being run inside of a AA type container with holder, cylinder with holder, and that is packly tighted graphite felt in pieces. But the important thing is that we're running at 4.8 volts for 6 days. Now, of course, we have to see much longer, under a longer time duration, if it would hold up. But so far, so good. Obviously, the voltage really did not go through the roof, meaning the resistance of the felt was changing. And we expect that the surface area would increase in contact with electrolyte. And if the surface area increases, resistance is expected to increase, and hence we would see a significant increase in voltage at constant current conditions. So what I'm trying to say is that one so far is very interesting, considering that most of these industrial supercaps with organics are kept at 2.7 volts. Okay, so there we have it. We'll keep you posted. And right now, the focus in this film is on the sample here, starting out just a number of minutes ago, 240 milliamps and at 3.55 with electronic load LED. Thank you for watching. Bye for now.